Okay. Hello, everyone. Welcome today and happy International Women's Day to all of you. Today, I'm going to be talking about designing secure cloud applications. But before we get into it, I want to say a few things and give a few benefits that come with moving things to the cloud. When you are doing cloud computing, it allows you to do a lot more for less. It's cost effective because you only pay for what you want to use. You have on demand self-service. You can get access to multiple resources, multiple things that you need for your application just over a network, over the internet. And this makes it easy for a lot of business to have one less thing to worry about, for a lot of businesses to have one less thing to worry about. However, with all of these new benefits comes some kind of responsibility. And I'm going to be explaining this, what I mean by this, in layman terms by using a very common example that is relatable to a lot of people.
Hey there, I'm going to tell you a story about what happens when you do not protect public resources. This house has water supply in form of a bucket at the compound. This is a housemate who actually needs water. He gets some into his bowl and goes back inside. This second person, who happens not to be a housemate, comes to the public area where the water is and makes it unfit for everyone to use by washing her hands inside. This housemate happened to be walking in the direction of the water and accidentally kicked it. Now all the water is gone. Why did this happen? Because access to the water wasn't properly regulated. How do we fix this? Take the bucket away and keep it in a safe place. Secure the house to prevent outsiders walking by from tampering with resources only meant for housemates. Connect a tap so that housemates get water in a structured way. The end.
As we've seen in that previous video, there's so many things that could happen. There's so many risks that could occur just because resources are not secured. And in that context, where we had the bucket of water shared amongst housemates and other people, is the same way you have your applications on the internet, because the internet is accessible to every single person on the planet that has internet access. There are no restrictions. That's the same way it's possible for your application to be accessed by multiple people. And if you don't properly regulate these things, who you want to give access to, how you want to control that access, and how you want resources to be given to people, there is a chance that terrible things could happen. One of the terrible things that could happen would be human error, human mistakes. This example in the previous video that was just watched was the person passing by accidentally kicking the bucket. In this case as well, things could happen like I'm a developer, right? And I am supposed to be deploying to production, but something goes wrong in my deployment and I want to change something, and then I accidentally go and delete the entire stack, delete the entire production environment, and now we have no application. Customers are calling something, what's going on? Everything is just wrong. This is an example of a human mistake that could happen because of resources not being properly regulated and security not being seriously put in place. Another thing is malicious attacks. If you do not properly secure your application or add or put the proper identity management things that would enable people that only have access to gain access to your application. Anybody can do anything, gain access to your application, gain access to your customers' data, and do unspeakable things. And sometimes, because of issues that might come up as a result of your customers' data being not properly used, or something bad happening to their data, or them feeling like you're using their data for something else, you might have a lot of legal issues, you might have some compliance issues, and that could be a problem. So in this talk, I would be sharing 3 patterns that that you should think about when trying to optimize for security in your cloud applications. But before I get into it, I would want to quickly introduce myself. My name is Adora, and I am a software engineer at Microsoft Mixed Reality. So in my day job, I spend time, building cloud services that are related to AI and mixed reality. I spend time building services that allow other developers build apps that properly blend physical and digital worlds together and give customers great experiences. I am a tech content creator at Adora Hack. It's a thing that I founded it's a thing I created. It's just where I share every single thing about tech that I know and learn, things about tech, things about my life as a software engineer, things about career growth. I write and I have a YouTube channel as well. I'm a co-founder of Unstack, which is a community that started out of Lagos, Nigeria, and I am also on the advisory board of VRAR Nigeria, which is a VRAR community which is the VRAR. So the VRARA Association is a global community, and they have the Nigerian chapter, and I am on the advisory board for that. So you can find me on Twitter at Adora Nwodo. So the first thing you want to do when you're thinking about an application that you want to build is run some kind of security checklist. And these questions you can ask yourself is, okay, what should this application have, right? What should this application have? And how do I need to secure this application? Because in asking yourself these questions, you would realize, the areas that you need to secure your applications. You understand what needs to be secure and how that thing needs to be secure. Few questions that you can ask yourself are, will my application contain sensitive customer data? Where and how will my application's data be stored? Will this application be available over the internet or just internally? How do I verify my user's identity? What sensitive tasks are performed on my application? Does my application perform any risky software activities? If your application performs any risky software activities, you might want to think about protection against malicious data. For example, if your application is the kind that would allow people upload images, people upload different things onto your server, you want to think about protection against malicious data, because somebody can create some kind of malware and change the extension to JPEG. And once that is uploaded, you don't really want to know what happens next. So you need to find a way to stop these issues from happening before they happen. If your application is going to be having sensitive customer data, you want to think about any data protection or encryption method for your application's data, for your customers' data. If you're going to be having users, you want to think about the way to properly authenticate, or like proper authentication and authorization for your users, so that nothing happens to them when they are using your application, or nothing happens to all the data that they store, or multiple things. And when I was getting this thing set up, I grouped these questions into different buckets. And at the end of the day, there are three main buckets. There are two main buckets essentially, and three main architectures. So there's the data protection bucket and there's the identity management bucket. And the three architectures can be split into two of these buckets. So the data protection bucket, there's a Gatekeeper Pattern, which I will talk about in a bit, and the identity management bucket has the Federated identity and Valet Pattern, respectively. So moving into the data protection scenario, let's talk about the Gatekeeper Pattern. When you have applications functionality, normally they are exposed, and they're exposed like by client requests. And if these requests are compromised for whatever reason, an attacker can gain access to your system and can do very despicable things, and the sensitive data will be exposed. Multiple terrible things could happen in your system. And a way to protect that exposure, a way to make sure that exposure isn't really a problem, is by introducing a gatekeeper into your application's architecture. And how you do this is, as opposed to having the host exposed directly to any clients, you introduce a gatekeeper before the host. And what happens is the gatekeeper is essentially what is exposed to the client that is making any form of request to your application. And the gatekeeper receives the request, it validates that it validates the request and sanitizes the request. If it's an invalid request, then nothing happens after that, or you can, that's more an implementation detail. You can decide what you want to happen if the request is invalid. And if it's a valid request, then request bubbles up all the way to the host, and then the host can call the service, call the storage, call the other resources, and every other thing that the request needs, and then gets the response back and send that response to the client. So when you use a gatekeeper, there's some benefits. Like I said, the request validation and it's limited risk, and we're talking about security. So security is also a benefit. Request validation, meaning that it's not every single request that the host processes. If it's an invalid request, it never reaches the host, and the host never really has to know what kind of request that was. And a real life scenario for the gatekeeper pattern would be, having a public endpoint and having an internal endpoint. So the public endpoint is what you expose to your users. The public endpoint is what the users can call. And at that point, when the public endpoint is called, the users have the gatekeeper role, which is in limited privilege mode. So when you have that role, there's only so much you can do. And once you've been able to validate that request and sanitize the request and call the internal endpoint, you now have full privilege mode to access the service and access other resources, because you now have the trusted role. And the next thing I want to talk about is the Valet pattern, which is the second scenario, the identity management scenario. So when you're thinking about the Valet pattern, it helps you securely control access to data by using a token that would expire after a given time. And you can use this token for authentication. You can also use this token for authorization. And the way this works, if you look at this diagram, is that the first thing that happens is, I want to request a resource. Let's say I want to request something from a storage account, but I don't have access to that storage account. I go ahead and request. As a user, I go to the application and I'm like, okay, this is what I want. And then the application validates the request and generates a token and returns that token to me. And with that token, I now have access to that resource. So with that token, I now have access to the storage account, and I can get the resource that I want to get from the storage account. I got this code snippets from the Microsoft documentation because I think it's really helpful in further explaining exactly what I am trying to say. So let's say we have a class called the value controller, and same way I am trying to gain access to my storage account, right? I have a blob service client and I have a blob container, and I want to get a reference so that I can upload something to a storage account, and it's supposed to return a storage entity SAS. I've designed what I want my storage entity SAS structure to look like. So it's going to have credentials, and it's going to have the blob URI. It's going to have the URI of the storage blob I need access to, and it's going to have some kind of token, which are the credentials that would allow me to gain access to that blob. So I get the blob, I create my key credentials, and I attempt to build my SAS token, essentially. So I pass in building my SAS token, which is when I am creating a blob SAS builder, I pass in my container name, I pass in the name of the blob, I pass in the start time and the time that I want my token to expire. And this is happening as the client. I have no idea this is happening. This is happening in code. So essentially, me as a client, when I make a request to this storage account, this is what's going to happen on my behalf. I'm going to get a token that starts now and expires after 10 minutes. So after 10 minutes, if I want to do something again on that storage account, I would need to make another request. And on my policy, I set permissions. So the only permissions I have on this storage account is write permission. So I can only upload things to the storage account. I can only upload things in the application. I cannot. And all these things, like, the storage account, obviously when you're building your applications, these concepts should be made abstract to your user, essentially. So all they know is that, they're going to be doing some kind of upload or something. And in that context, they only have write permissions. They can only upload something, but they should not be able to download anything because you only set write permissions in your app. And then you can return your SaaS by, constructing this storage entity SaaS, adding the URI and adding what the SaaS token is. And now I can go to my application and try to upload something to this particular blob using the URI, and my token would be the SaaS token that I have. And after 10 minutes, I shouldn't be able to use that token again. So now let's talk about another pattern in the identity management scenario called the Federated identity pattern. So this helps separate a user's authentication from the application source code and delegates these other authentication and authorization things to these auth providers so that you can focus more on building the code. And let's look at like claims-based access control, for example. So I am a user and there's a service that was built, and this service uses some kind of identity provider or STS to generate tokens for users. So basically, as a service, I'm using that STS. So as a user, when I authenticate and I request this token, I am calling that provider, and then I get the token as a user from STS, and now I can take that STS token to the service, and I'm like, okay, this is my token, this is who I am, and the service should be able to identify that this is this particular user, and these are the roles, these are the claims present in this user's token. So this is what this user has access to. These are the roles that the user can perform. And then just go ahead to allow me do this thing. So one of the benefits, so you can use Federated identity pattern in single enterprise sign-ons. You can use it with multiple partners, and you can use it in normal SaaS applications. Like I said, one of the benefits of using this is that you only get to focus on what is important. You build your app and you have all the authentication bits taken care of for you. Another example, as we can see in this diagram here, is, so I have my own service as a company, I have my application, and I am using this STS, right? I'm using this identity provider. So essentially, it's like, okay, I have this company, and all my staff or everyone that has access to this application is at least has some kind of identity here, is registered here or whatever. So if anybody that does not belong to this tenant, if anybody that does not belong to this company tries to get access to my application, I can basically kick them out because I know that it's not them. And now that I've talked about these 3 security patterns, there are other ways that you can enforce security in your app. And one of them is by using multi-factor authentication. So depending on the kind of application you're building, sometimes multi-factor, one password is no longer enough, being very honest. So multi-factor authentication by having like a third-party authenticator app, or sending OTPs to people's emails or people's phones, or having some kind of security question so that even when they go ahead and put their password, they still have one other auth level to pass through before they're able to gain access or perform a very sensitive task. Something else is, as developers in your engineering teams, implementing JIT access for resources. And going back to the initial video that we watched at the beginning of this talk, if there was JIT access to these particular resources, we would have been able to prevent some things. So if there was JIT access, basically what happens is before you gain access to the resource or before you are able to do something for any production resource, you need to request access from specific admins for to be able to do this thing, and then the admins need to verify that what you're about to do is not going to cause any harm, and then you can go ahead and do it. And after a stipulated time, your access will be revoked. So if you're requesting access for like 30 minutes, after 30 minutes you don't have access anymore, and you'd have to request access again if you have more things to do. You should use stable authentication and authorization platforms. This is what we talked about in the Federated identity pattern. These platforms already are in the auth business, essentially. They've had this going on for a very long time. They've had problems, they've been hacked, they've had issues, they've mitigated it, they solved these problems. You can use their tools essentially so that you don't have to go and think about all these extra things, and you are also not reinventing the wheel because these solutions already exist and are waiting for you to use them. You should also do re-authentication for some actions. If you're doing some kind of financial transaction and it's time to transfer money out of an app or something, you might want to tell the user to put in their password again, or you might want to tell them to put in some kind of code or something just to be sure that, okay, this is actually the person that is making this transfer or doing this particular action. You should also think about reducing your attack surface. The wider your attack surface is, the easier it is for attackers to get into your system. So basically, your attack surface is multiple places in your service, multiple places in your system that exist. So for example, if you have 100 VMs and you're only using like 50 or you're only using like 60, then you shouldn't have those 40 not doing anything, because you're only using 60. Those 60 are the ones that are running. If someone gets access to one of these VMs that you're not using to do anything, they can use that access to find a way to get to active computers and do very unspeakable things. So learn to reduce your attack surface. Also, this doesn't help with security, but it properly helps in cases where your application is down and you need to debug or do things to get it back quickly or get it set up again. So handling errors and exceptions gracefully, handle these errors, log them properly, monitor your service and trigger alerts when things happen. These two go hand in hand, so that when people see things, when something bad happens or when something breaks, it's easy for someone to go and see what happened and possibly fix it, and your response time is pretty fast. Also, encrypting sensitive data is very important. If your customers are going to be having some kind of sensitive data in your application, you would want to think about ways to encrypt this data and not just leaving them in your apps as plain text, because that could be very problematic. Implementing fail-safe measures as well, so that your applications fail gracefully, and when they do, they can always be restarted without any issues. And something else is considering threat modeling. So thinking about threat modeling, it's properly planning ahead in some way to think about the possible threats that could exist in your system and how you want to go about mitigating these different things that could happen. So let's look at Stride, for example. So if spoofing attacks is a possible threat in your system, then you might want to think about enforcing HTTPS connections so that you don't have that authentication problem. If there's a chance that people will tamper with your system, tamper with resources, then you should also try to get valid SSL or TLS certificates to protect the integrity of your application. If repudiation is a problem, then you need to enable proper monitoring and instrumentation in your applications so that that doesn't become a problem. If there's a chance that information from your system is going to get leaked, or someone can hack into your system and every single thing is just open in plain sight for everyone to see. You might want to think about encrypting safe, sensitive data to protect the confidentiality of your users. If denial of service is a possible threat, then you might want to enable monitoring and proper instrumentation, like I have said, so that when your service, for whatever reason, is down, people can, if the service is properly instrumented, there's logs everywhere and different things. People can see what the issue was and quickly fix it, and your service can become available again. If elevation of privilege is the threat, then you want to use a secure identity management. You want to use a secure identity management tool as how you plan to mitigate that threat, so that you can still so that authorization isn't a security issue, so that whoever is coming to your system, you know who exactly this person is, you know who exactly this identity is, and can say these are the actions that this identity is supposed to be able to perform. These are the privileges that this identity is supposed to be able to do. Other important things I would say are using secure libraries, updating your service dependencies to prevent vulnerabilities, and avoiding hard coding. If you need to reference any secrets, reference them from a secrets manager. Don't hard code stuff into some kind of environment file or something like that. Reference them from a secrets manager. If you also need to, if you are sending data across and this is data that is possibly sensitive, also think about encrypting that as well. If you want to learn more about security, these are very helpful links that I have put together that I think would help you on your journey to learning about security patterns and creating more secure cloud applications. And thank you very much. I'm so glad that you watched my talk. I'm so glad that you came to join. I'm so glad that you came to listen. And if you have any questions, I believe you can ask me these questions on Twitter. My handle is here on the screen, and I would be happy to answer. Thank you once again, and I hope you enjoy every other talk from every other speaker.